Production model is a little different than the income statement model we have been doing. It deals with how do you use the same amount of parts to make different objects and then figure out what is the best mix. Let me explain. So imagine you have a Mexican food restaurant. And as everybody knows, or everybody should know, all Mexican food is made out of pretty much the same ingredients. So we have multiple objects here, your burritos, enchiladas, fajitas, and quesadillas. And they're all made out of the same ingredients: tortillas, chicken, cheese, salsa, lettuce, and rice, right? They just use them in different amounts. So a burrito has one tortilla, while an enchilada has two. A fajita comes with a stack of four. But when we talk about lettuce, fajitas and burritos have lettuce, but enchiladas and quesadillas do not. And rice, enchiladas, you have rice on the side. Burritos, you have rice inside. But on fajitas and quesadillas, no rice. Okay. Now, the price. We charge a different price for each one of these objects: $6.99 for burrito, $8.99 for an enchilada, $7.99 for fajita, and $5.99 for a quesadilla. And finally, we have the notion of capacity. Like, in order to make these goods, we already have to have a certain amount of stuff on hand. So how many tortillas do we have? How much chicken? How much cheese? How much salsa? So on and so forth. So assuming that this is the problem that the case is laid out, I've already created it here. Now we need to create our inputs. So unlike in the other kinds of models, here our inputs will be in a different place other than the upper left hand corner. So we're going to have our production, and here we are looking at how many burritos, enchiladas, fajitas, quesadillas we're going to make. Now, if we have one of each, and each one of them costs this much, we should be able to figure out what our revenue is going to be. So our revenue is equal to, we could multiply it out. It would be B9 times B11 plus, and so on and so forth. An easier way to do it is to use sum product. So it'd be sum product these, comma, the sum product of those, which is basically saying each one will be multiplied times its match, and then all of them are added together. So right now that's $29.96. If there's two of these, it should be $8.99 higher, which it is. It's $38.95, and so on. So if we had 10 burritos and 0 everything else, it should be $69.90, which it is. Okay, so you see how that works. So I'm going to do the same thing with, okay, so we have the capacity. We're going to create another column called usage, which keeps track of how much of our ingredients we're using because of each thing that we're making. So here, this will be equal to the sum product of our production and our tortillas. And I'm going to lock my rows on the production. And if you don't know what that is, you're going to need to go back and look at absolute versus relative addressing. And so 10, which makes sense. So I have 10 burritos, 0 everything else, and each burrito uses 1 tortilla. I've used 10 tortillas. And if there's just 1 of everything, 1 plus 2 is 3, plus 4 is 7, plus 2 is 9. My usage should be 9, and it is. And because I used relative addresses, I can just copy this down, and voila. So what we have here is a model where, based on these production items, we have a revenue that is calculated, and we have a usage that can't exceed our capacity. We can't use more lettuce than we have. So now I would go to Solver, My objective is my revenue. My changing cells are going to be these guys. And my constraints are that my usage has to be less than or equal to my capacity for each thing. Now I could select them each one by one, or, which is kind of cool, I can just select them as a group. So all of my usages have to be less than or equal to their corresponding capacities. So I'll add that. My productions all have to be greater than or equal to 0. I can't make a negative burrito. And my productions all have to be an integer. And let's take that. And I believe those are all of my constraints. So this would be enough if I'm just doing nonlinear. If I'm doing evolutionary, because of the way evolutionary works, you need both a bottom and a top constraint for your inputs. And the way that I would pick those is I would pick the maximum value. So when we look at the production, what do we have the most of? We have chicken, 160 units of chicken. There's nothing that only uses 1 unit of chicken, but we can still say it has to be less than or equal to 160 because there's no way we can make anything on here more than 160 of it because they all need chicken and we only have 160 units of chicken. We'll cover that more in class. And so if we do that, we can run it as evolutionary, hit solver, and then wait for it to come back with an answer. Okay, evolutionary is done. We finally came back with an answer. It seems the best combination is for us to make 13 enchiladas. And apparently, since I'm maxing out the rice, I maxed out on the number of enchiladas I could make, and then the next most profitable thing were the fajitas once I had run out of rice. And then I made 2 fajitas, and I can make $132 with the ingredients that I have on hand, having made those things. So this is our first production model. This is the format you want to look at when you build it. Generally speaking, your ingredients or your components or whatever it is you're making the things out of listed down the side. The objects you're making listed across the top. You can do it the other way, but then you need to shift how everything else is oriented and using some product to calculate our revenue and our usage. See you in class. Bye.